So yeah, hi everyone. So I'm Deepak and this is Jilai. So this is our talk about the motor upcoming, I would say, because there's not right in the main line. So this is something which we worked on like over the past few months. Or more, not me, more. I think Jilai worked on this one. So yeah, it's just a quick overview about like what we did and like what's happening right now. Uh, yeah, we had to follow this template, so we have this whole set of topics. So we are like first we talk a bit about Zeiss and like why do we need a motor control API and like how did we start, and then like Jilla will take over from here, like where he shows about like two different approaches which we used, and finally like what's the state of the API right now. So yeah, like I guess most of you guys like know about Zeiss. So it's a 170-year-old company, and I think it's from Jena, it's from where Tobias comes. And we do a lot of how do you say work on optics and optoelectronics. So I guess you guys would have heard about ASML. So Zeiss is a partner with ASML. They may produce all the lithographic equipment which you need for process making chips. So this more about Zeiss. And we guys are from the medical sector of Zeiss. So our firm is called as Carl Zeiss Meditech. So we are based, we guys are based in Oberkochen. That's in the Ostal region of Baden-Württemberg. Headquarters is in Jena, and yeah, we have quite a couple of locations where like Zeiss is located. Yeah, global company. And these are some of the medical devices what Zeiss makes. More like quite a lot are like related to eye surgery. So we guys are working on eye surgery equipment. So these are like surgical microscopes, what you see down over there, and some of the equipment are used for cataract surgery. So yeah, this is what we work on usually. And well, because it's a microscope and you have a lot of things which move, so that's where you like use stepper motors or motors in general. So that's how like we had faced this problem. So like yeah, like I said, like motors are a part of our devices what we make, and Zephyr supports a lot of sensors. So you pick any sensor you want, and you have like a running API, and it has a standardized API like to fetch values, like get values and query values, but there's nothing on the actuator side. And this is our typical, like how our stepper motor, how we use, like we don't directly talk to the stepper motor, like in between the motor, we have a stepper motor controller. In our case, it was the trinamic stepper motor controllers. These are like quite, how do you say, like quite robust and like provide a lot of features. And you talk between the controller talks to the stepper motor controller using either SPI, I2C or UART, and which in turn is connected to the stepper motor in the end. So yeah, that's it. So how did we start? Like back we started off with the Zephyr 3.5, and back then we didn't have an SPI shell. Like back then we had an I2C shell, so you could talk to an I2C device when you just compile config I2C shell, so you could like just directly talk to the device. But back then there was no SPI shell. I think it came out recently on 3.7. It's right now in the mainline. So what we did was like so what was done with the CAN shell? So with CAN shell, you can like say like CAN device, send so and so CAN message. So what we did was like we just took made a shell based on the SPI device as the background. So we just say like, I say my device, I want what register, and I can say either it's a read or a write. So it just sends the SPI message. So the data sheet had this specific example over here, like where we try writing a couple of values into the to the controller, which in turn would like start rotating the motor. So with this rudimentary shell, so we got it working. We saw like our hardware concept works. Just like it was not like how Tobias suggested. Like we had a board in the beginning with, and we just started testing if like our peripherals work or not. So that was like back then. So I think I'll pass it over to Jilla because he did most of the work over here.
So yeah, thank you very much, Deepak, for explaining what we did till now. So yeah, as Deepak just mentioned, right, we work with these dynamic controllers, and they are actually pretty fancy, and they have quite a bit stuff inside it. And one of the good things about those dynamic controllers is like they can support more than one motor. For example, the TMC5041, it can drive two-stepper motors, right? So one good thing about like the entire evening today is that like a lot has been talked about device tree, right? And so what we did is we tried exploiting different features of device tree. For example, there is a feature called bus and on bus. So for instance, like when you have an SPI controller, right? So what does an SPI controller do in the background? If you go into the YAMLs, you will see that some controller basically opens up this bus called SPI. And whenever you have a device, basically in this case, it would be a motor controller, TMC5041, it's an SPI device, right? So what we thought, or actually we were kind of inspired by someone else about it. And yeah, so the idea was that a SPI device, which is basically, how do you say, a child node of SPI controller, right? So this SPI device could actually open up a bus called motor bus. And eventually, your motor, which is actually connected to a motor controller, could become a child of that controller. So we were trying to kind of, how do you say, propagate this idea of controller device to the motor level. And yeah, so that's how the device tree looked like in the beginning. I mean, what we thought is like, for example, stuff like gear ratio, microstep resolution, right? Like since there's stepper motors and all, this could be entirely built into the device tree like this, right? And then at the end of the day, you would have two different device drivers. One device driver would be for the motor controller, and the other device driver would be for the motor. But we soon came to realize that when you have two different device drivers, these drivers, they need to communicate with each other somehow. And this interface proved to be really complex. But nevertheless, we still started the RFC, right? That's the number 68547. And this initial thoughts that we also had was actually also kind of, how do you say, reciprocated by the community that, hey guys, you're not on the right path over here. You need to stop over there. So, but the community criticizes and also it helps you at the same time. So somebody from the community actually had kind of tried doing something with stepper motors in the past, and then we were pointed to one of those, how do you say, older PRs, and then we came up with this child binding approach. So the child binding approach, like, is it visible right towards the back? So let's not go from left to right, let's go from right to left over here, okay? So the idea was that you have a generic motor, right? Now, more or less, each and every motor would have something called a gear ratio, right? This motor is, again, child of a motor controller. Now, this motor controller is a generic motor controller. It could be a stepper motor controller, BLDC motor controller, or whatever. Now, this motor controller is, again, child of stepper motor controller. Stepper motor controller, again, has a child called stepper motor, which, again, has some generic stepper motor properties like steps per revolution, microsteps resolution. So I think you guys can see like how much time we spend just with the device tree over here. Yeah. So like if you keep on propagating it towards the left, you would eventually end up with your dynamic stepper motor controller, right? And it would still have like the generic properties from a normal motor, right? Like this gear ratio, and then it would have like highly specific properties, like something like a stall guard setting, which is just offered to you by this dynamic stepper stuff, yeah. And however, like this approach again had a few assumptions, right? Like we kind of thought, okay, that the drives would be linear and all. And I think somebody in the community also said, like, what would you guys do if the drive is an elliptical drive, right? You cannot actually kind of build it with this kind of structure. And again, the drivers are also kind of quite complicated. So then what we did after that was remove the motor altogether. Just talk about stepper motor controller. So you see the device tree has, like, it has reduced a lot. I mean, so the PR is still open, right? 68774. We have kind of received some requests to change over there, and some feedbacks have already come down. And yeah, so initially when we started this entire PR, it was almost like 3,000 lines of code which we were trying to bring in. And yeah, I mean, we were not successful at it, right? So I think now we have reduced this entire pull request to 300 lines of code. So what we would like to say to everyone is, like, when you're trying to bring this kind of new API or new feature to Zephyr, try to make it as small as possible. Like in the beginning, if you're trying to propose a new API, like just something like this DTS bindings and yeah, the API, they're more than enough to actually put your stuff in it and like explain to the community what you're trying to do. And then if you just compare these two approaches, like you see, like we have kind of removed this entire motor stuff over there, right? Gear ratio has disappeared. And yeah, we just have like controllers now. And yeah, I guess that's it. Like yeah.
Look at it from how to say the final whatever comes out of the drive. I mean, like towards the end, like you have a couple of gears, and then you like look. We were trying to track like what is the end position over there, but we decided like adding that complexity like leads to a lot of questions. So we just stuck to the controller. Like whatever happens in the motor shaft, like we just track this position and nothing. Like it's indifferent for us. Like what type of gearing is connected, or like if it's a linear drive or an elliptical drive, it's indifferent for us. Yeah, so that's like the gist of like this PR or this RFC. Yeah, any questions? Yep.
You also have a video file. So you talked a lot about the device design. But do you also have the unified motor API on the
I think Gilad can answer.
Yeah, so there is actually a motor API, and I mean, yeah, if you go to that 68774 pull request, you'll be able to see the API over there. I have not put the photos of the API over here, but the idea is to actually, again, simplify the API by splitting it into two parts. Like there is something called a basic set of functions, right? Which let's say each and every motor driver needs to offer, for example, enabling a motor, running it, right, stopping it, and like, so there is a basic set of functionalities and everything on the top, right? For example, let's say something like the stall guard setting, it's like dynamic specific. It's kind of put into some kind of an attribute list, and you can get and set those attributes. So it's yeah, kind of following that approach right now. Yeah.
And you switched off the motor controller boards, we could just do that in the device tree and you wouldn't have to change.
Yeah, for sure. I mean, it's, how do you say, it's like a generic Zephyr API, right? And of course, the API is designed like that you would be. But again, I mean, for example, this again boils down to the question, right? If you, for example, if your code uses something like a stall guard setting, you would, of course, for sure need to have a controller which provides this functionality. For example, Dynamic has this feature where there is something called sensorless stalling. So basically, you don't need an actual end stop. It just recognizes an end stop via back EMF. So of course, like those features need to be taken care of. But like let's say generally, if you use something like a DRV8826, like what Tobias also showed, right? Like one of those Polulu stepper motor drivers, like the basic ones, it should also work with this driver as well. Yeah. Yeah. Yeah, that's the whole idea. Yeah? At the end of the day, yeah, you basically just say, okay, move this many steps, or yeah, start, stop, exactly. Yeah. Yeah, so that's the idea. For example, this is stall guard setting is something that we extensively use right now in our application, in our development, because yeah, while testing, you never know like what's the exact how do you say resolution that you need to use over here. But yeah, that's the idea, because you just need to, as I think somebody just said, right? Like you don't put any runtime things in device tree. You just have this things that you already know at the compile time. Yeah, but yeah, so this kind of features, of course, you could put in over here. Yeah. I guess that's it.
Just one comment on the like on the gear ratio. It is a hardware property, isn't it? So you had to pull it out. I followed the PR and the RC, and I didn't know all of that. But it's a hardware property that you now somehow have to hard. What did you do? Is it a K-config symbol, or where? Or is it hard coded into the C code now?
I mean, like we have a K-config symbol. It probably converts the steps.
Yeah.
Yeah, we have actually kind of put it into K-config right now. Yeah. But yeah, I mean, it would have been nice actually to have something like that. But yeah.
wanted to do the unified motor approach, and stepper motors they took different something so.
Yeah.
For the one thing, what happened, what we actually not shown over here is just like trying to put a stepper motor controller API was not so easy. Like the entire community wanted to push for a motor API, and yeah, so we kind of tried to restrict this entire topic to just controllers and all. And that was, how do you say, a compromise that we had to drop something like a gear ratio. Yeah, but yeah, but I think it's a good compromise.
How far into the process are you? Like, are you expecting to be merged very soon?
I don't think so. I mean, we have received one approval. So any Zephyr members over here who could give another approval to us? Yeah, we need 2 votes, right? Like 1 vote we have. Yeah. So we are waiting just for 1 more vote. Yeah, but I mean, it's how do you say? It's a process that takes some time, and you need to have some patience, right? Yeah. But yeah, hopefully it would soon be there, and yeah, let's see how it goes ahead. Yeah. So Zephyr is not just related to IoT stuff. I mean, it's also like driving motors now. Yeah. So I guess that's it. Or